In Chapter 9, we're going to be looking at correlation between our data and to see if there is a linear relationship that occurs between two sets of data. In this case, I'm going to be going through an example from page 499 of your text, number 37, regarding earthquakes. And before you do anything in Chapter 9, you will need to turn your diagnostic on. And your diagnostic on is done through your catalog. So second, catalog. Turning it on first helps. And I'm going to arrow all the way down to the D's. Notice these are in alphabetical order. And when I get down to diagnostics on or off, I want to hit enter by diagnostic on. And hit enter again, and it just says done, and you're ready to go with your linear regression. Alrighty, so the example I'm going to be going through is on page 499 of the text, and what we're going to be doing first is entering into list 1 your X values and into list 2 your Y values. So that has to be done before you can do anything else. There are some things that you should know before you start with working with this chapter. They use this Greek letter rho, and it's just the Greek letter R. And when we're dealing with linear relationships, we're going to be looking for R values, and since we only have a couple R's in our alphabet, they went to the Greek alphabet to find the correlation coefficient. It looks like a P, but it has no definition. It just kind of comes up and around and forms a little loop at the top. So that's the Greek letter rho. You are always going to have a standard of H naught and HA being rho equals 0 or rho not equal to 0. Either it is a significant correlation or it is not. Now, the other thing you're going to have is in the back of your book, on page A27 in the back, they have table 11, which has your R values, and so what you're going to be doing is comparing using N, which is the number of sets of values. So in our case, we have 8 sets, so we'll be down here at the number 8. And then you go by an alpha of 0.05 or 0.01. Our case, we're going to have n equals 8 and alpha equals 0.01 for a value of 0.834 for our comparison. All right, so back to our values for our earthquake problem on number 37, page 499. Notice we're using alpha of 0.01. And what we're going to be doing is, first of all, making sure, I've already put mine in, so stat and edit, and notice my values are all in there for L1 and L2. If you want to plot it, you hit second and stat plot. I turned on plot 1. And I made it a scatter plot since that's what they were requesting. And make sure your X list is L1, your Y list is L2, and you can choose any marking you would like. Then to get it to plot it, I go under Zoom and I arrow down until I find Zoom Stat number 9 and hit enter. And it plots those values out there. So if you want to see, does this look linear? Yeah, quite possibly it does. If I look at this, it is definitely going kind of up in that direction. And so, yeah, there's a strong possibility, in my opinion, that that could be a linear relationship. Now I'm actually just going to go ahead and run the test. Stat, tests, and this should actually kind of make sense. You are going for a linear regression T-test. You're going to have to tell it which lists your X and Y lists are in. Always use one for frequency. You only want to use each list once. It's not equal to, remember we kept it easy with equal to and not equal to. We don't have a regression equation. We are just going to go ahead and calculate. Now, here you have all the information you would need. You have your t-value if you're looking at using a t-test to compare. You have a p-value for probability, 6 degrees of freedom. If you read the chapter, that's n minus 2. So if you wanted to come up with the line, y equals negative 17.41 plus, and if I arrow down I'll get my b value, 0.583x. So I can substitute this a and b value in for my a and b up here, and that would actually give me the linear equation. I'm going to keep arrowing down because what we're after to compare with our chapter or our table 11 is this r value of 0.848. And so what I'm going to be doing is comparing my 848 for an r value, and I'm comparing that to back in my table 11. Notice this was 0.834. So my 0.848 is greater than my 0.834. If this is larger than the value from the table, there is a significant correlation. So all it takes is for that to be bigger. I can't even spell relation this morning. And even if it's negative, some of your formulas, they're going to have a negative relationship. That doesn't mean they're not linear. So if I would have ended up with an R value of a negative 0.848, what you're looking at is the absolute value of this. So you would have to take the positive value regardless. So no matter if it's positive or negative, as long as the absolute value of it is greater than the value in the table, there is a significant correlation.